Hello everyone and welcome back. In this video we're going to look at using the z-table in order to solve certain problems that deal with the standard normal distribution. Now let's suppose that y is normally distributed with a mean of 100 and a standard deviation of 5. So what is the probability of observing a value greater than 107? So with these types of problems, it's always a good idea to draw a picture. So let's draw our model. It's a normal curve that has a mean of 100 and a standard deviation of 5. So we can write this as mu equals 100 and the standard deviation, sigma, is equal to 5. Now the probability that we observe a value greater than 107 will correspond to the area under the curve to the right of 107. So we want to determine this blue shaded area. So instead of working with this normal distribution, we can standardize the data by using a z-score transformation so that we can work with the standard normal distribution instead. So recall that a z-score is the observation y minus mu divided by sigma. So if we calculate the z-score for 107, we get 107 minus 100 divided by 5, which is 1.40. So now what we can look for is the area under the standard normal distribution, which has a mean of 0 and a standard deviation of 1. So finding the area to the right of 107 in our first normal distribution is equivalent to finding the area to the right of 1.4 in the standard normal distribution. And so mathematically we can write this as the area to the right of 107 is the same as the area to the right of our z-score of 1.4. And because the z-table gives us areas to the left of the z-score, we will want to use the complement rule in order to find the area to the right of the z-score. And so using the complement rule, this is equal to 1 minus the area to the left of 1.4. So using our z-table, the area to the left of 1.40 is 0.9192. And so the area to the right of 1.40 will be 1 minus 0.9192, which is equal to 0.0808. And so the probability of observing a value greater than 107 is 8.08%. So now what is the probability of observing a value between 98 and 105? So let's first draw the region. So for a mean of 100, we have values of 98 and 105. And so we want the area that falls between these two values. And this will give us our probability. And so once again, instead of working with this model, let's standardize our data and work with the standard normal curve. So let's find the z-scores for 98 and 105. So we'll call this z1. So the z-score for 98 is 98 minus 100 divided by 5, which is negative 0.4. And the z-score for 105 is 105 minus 100 all over 5, which is equal to 1.00. So now using our standard normal curve, we have our z-scores of negative 0.40 and 1. And so the area between 98 and 105 is equivalent to the area between negative 0.4 and 1 for the standard normal curve. And keep in mind that the z-table gives us areas to the left of z-scores. So to determine the area of the blue region, we can look up the area to the left of 1 and then subtract it from the area to the left of negative 0.4. And so mathematically, this would be the area to the left of 1 minus the area to the left of negative 0.4. So looking up 1.00 in the z-table gives us an area of 0.8413. And looking up the z-score of negative 0.40 gives us 0.3446. And so subtracting these areas gives us 0.4967. So the probability of observing a value between 98 and 105 is 49.67%. So now what is the value of y that corresponds to the top 10% of data? So let's first draw the region. So this time we know what the area underneath the curve will be. And what we're looking for is the value of y, which corresponds to this area. So the top 10% of data will have an area of 10%, or 0.1 as a decimal, to the right of the value of y. So how can we determine this value? Well, once again, let's consider the standard normal curve. And so what we could do is look for the z-score, which corresponds to an area of 0.1 to the right. So we'll call this z star. And then we can use the z-score formula and work backwards in order to find the value of y. And keep in mind that the z-table gives us areas to the left of z-scores. What we need to do is determine the area to the left of z star. So we can use the complement rule. So if the area to the right is 0.1, then the area to the left will be 1 minus 0.1, which is 0.9. And so what we want to do is look up the two closest values to 0.9 inside of the z-table. So the two closest values inside of the z-table are 0.8997 and 0.9015. So let's write down their corresponding z-scores. And so the table tells us that the area to the left of 1.28 is 0.8997. The area to the left of 1.29 is 0.9015. So notice that 0.9 is closer to 0.8997 than it is to 0.9015. So for this case, we will pick the closer z-score instead of averaging the two z-scores. And so this tells us that z star is 1.28. And now that we have our z-score, we can use the z-score formula to determine the value of y. Recall that the z-score is equal to y minus the mean divided by the standard deviation. So our z-score is 1.28. We are looking for y. The mean is 100, and the standard deviation is 5. So we can rearrange and solve for y. We have 1.28 times 5 is equal to y minus 100. And so y is 1.28 times 5 plus 100. And so this gives us a value of 106.4. So let's take a look at another example. Suppose that the time to complete an exam is approximately normal with a mean of 75 minutes and a standard deviation of 5 minutes. So how much time should be given so that 80% of students can complete the exam in the time given? So let's first draw our model. So we have a mean of 75 minutes and a standard deviation of 5 minutes. So we want to find the time so that 80% of students can complete the exam. So we're looking for the time y such that the area to the left is 80% or 0.8. So like in the previous example, instead of working with this model, let's start with the standard normal curve. So we can determine the z-score, we'll call this z star, which corresponds to an area of 0.8 to the left of z star. So we want to look for the two closest values to 0.8 inside of the z table. So looking inside of the z table, the two closest values to 0.8 are 0.7995 and 0.8023. So let's write down their corresponding z-scores. So the table tells us that the area to the left of 0.84 is equal to 0.7995, and the area to the left of 0.85 is 0.8023. So notice that 0.7995 is closer to 0.8 than it is to 0.8023. And so we will choose the closest z-score in this case. So z star is going to be 0.84. And now that we have our z-score, we can use our z-score formula to determine the value of y. So our z-score is 0.8. Y is what we're looking for. The mean is 75, and the standard deviation is 5. So rearranging and solving for y, we have 0.8 times 5 is equal to y minus 75. So y is 0.8 times 5 plus 75. And this gives us a time of 79.2 minutes. And so 79.2 minutes should be given in order for 80% of students to complete the exam. Now in the next problem, suppose that in a local high school track meet, the amount of time to run 100 meters follows a normal distribution, with a mean of 25 seconds and a standard deviation of 3 seconds. So what time corresponds to the fastest 5% of the local high school students? So let's first draw our model. We have a mean of 25 seconds and a standard deviation of 5 seconds. So now the region which corresponds to the fastest 5% is going to be the left tail. So let's call the time y, and the fastest 5% is going to be this time with an area of 0.05. And so if we work with the standard normal curve that has a mean of 0 and standard deviation of 1, we can look for the z-score, which corresponds to an area of 0.05 to the left of z star, and then we can work backwards to determine the time y. So we want to look for the two closest values to 0.05 inside of the z table. So the two closest values to 0.05 inside of the z table are 0.0505 and 0.0495. So let's write down their corresponding z-scores. So the area to the left of negative 1.64 is 0.0505, and the area to the left of negative 1.65 is 0.0495. So notice that 0.05 falls right in between these two areas, and so we will average the two z-scores to find z star. So negative 1.64 plus negative 1.65 all over 2 is negative 1.645. And now we can use our z-score formula to determine the value of y. So we have negative 1.645 is equal to y minus 25 all over 3. So negative 1.645 times 3 is equal to y minus 25. And so y is negative 1.645 times 3 plus 25. And this will give us 20.065 seconds. And so the time corresponding to the fastest 5% of local high school students is 20.065 seconds. So now we're going to mention a few properties of the normal model. When we shift or rescale a normal random variable, This will give us a normal random variable, but with a new mean and standard deviation. So when we standardize into z-scores, we are effectively changing the mean and standard deviation, but it's still a normal distribution. When we sum two random variables, this will generally produce a different probability model than the ones we started with. However, if we sum any number of independent normal random variables, then this will also be normal. And this will be very useful for us when we look at comparing two different populations in inferential statistics. So this will conclude our lesson for this video. In the next video, we will look at a special type of models, which are called sampling distribution models. And I'll see you then.